Hey guys, today we are looking at 3.1 domain and range. So continuing along what we talked about on Tuesday, Wednesday of this week with functions. Our domain and our range are really just another way of describing our functions, specifically what we have for possibilities for our inputs and our outputs for that same function. So you can see our definition here in box 1 for domain and range. The domain of the function is just a list or a set of all the possibilities for our x values or inputs. And then our range, defined the opposite way, is a list of all of the possibilities for our y values or our outputs. So we have two different ways that our domain and range can be written, and it really depends on what kind of function we have. We have these two different things called discrete functions and continuous functions. Now, certain class periods yesterday, I did kind of preview discrete versus continuous when we're looking at our graphs, specifically when we're identifying if something was a function or a relation from the graph. But a discrete graph, what discrete means is we have just these set of points. So they're disconnected. There's space in between the different outputs, inputs, outputs, or points on the graph, where continuous is a solid line or a solid circle or whatever the case may be. But there's no space in between our points. Everything is continuous between a certain number of things. So the way that we write those will be two different things. Because discrete graphs, discrete functions really, we just write as a list of the points that we have for our x values for our domain and y values for our range. And then our continuous functions will be defined a little bit differently with intervals. So we'll have to use our inequalities that we talked about last chapter. So heading over here to box 2. Box 2 is just all about writing your domain and range from our three discrete, what I call discrete different representations. So just a set of points from a table and from a mapping. So when we're going through and listing out our domain and range, if it's just a set of coordinates, remember that all of our coordinates are always x, comma, y. So that means the first number in all of these coordinates are going to be x values, so they're going to be part of my domain. All of the second numbers in the parenthesis in my coordinates are going to be outputs, so they're part of my range. So all I'm going to be doing here for my domain and range is just making a list of all the x values or y values that we see in this function. So for my domain, specifically the x values, I'm going to underline these right now. So 1, 2, 3, 4, and 5. The way that we list this out, because it's a set of numbers, we use these fancy brackets, and then we just list them out 1, 2, 3, 4, and 5, and then we close our fancy brackets. To draw those, just a little tip, the way that I first learned how to do these until you can do them successfully, I drew an S and then a 2, and that kind of makes the fancy brackets without having to actually do it in one fell swoop, one motion. So then for our range, we just have to list out our y values. So -2, 1, 6, 13, and 22. And that's our range. The one thing we have to keep track of, and the only thing that really makes a difference, if we have any repeated values, we only have to list it once, because our domain and our range is just a list of the possibilities for our x and y values, not the number of times that we see those x and y values. So if you had any repeated x values or y values, you'd only list it once in that domain or that range. And that's going to be important when we look at number 2, because here I find these, just like with identifying functions versus not a function, these mappings I find really easy because they already laid it out for you in terms of inputs and outputs. This first thing over here in blue is a list of all of our inputs. That's going to be our domain. So all we have to do is make our let's try that again. Make our fancy brackets. -10, -8, -6, -4, -2. Close my bracket. That would be my domain. Those are all of my inputs over here. And then my outputs, I only have 2 of them. Even though I have 5 different inputs, they all go to the same 2 outputs. So my range only consists of 1 and 2. And that's it. I don't have to repeat them over again, even though I have 1 that gets mapped to twice, 2 that gets mapped to 3 times. I only have to list them each once in my domain, or in this case, in my range. Okay, so then kind of that same thing happens here when we're talking about our domain for number 3. If our inputs are 16, 1, 0, 1, and 16, I really only have 3 x values that I see in my table. So I'm going to go ahead and just list these 0, 1, and 16. Usually we put it in ascending order, so from smallest to biggest. That doesn't really matter in terms of having the correct answer, as long as your set is correct, as long as you have all the numbers that need to be in there and not more than what you need, then that's fine. For my range, all 5 of those are unique, so I'm just going to list out, trying to rush through it here, -2, -1, 0, 1, and 2 would be my range. And again, just listing out my x and y values from a table, from a mapping, and from a set of points. What gets to be a little bit different is when we start talking about our graphs. Now, our graphs are going to be still either discrete or continuous. We saw both of these on the homework yesterday and in the textbook. When we're talking about a discrete graph, that's what these look like. So this is a discrete function. Again, notice we've got space in between each of our points on the function, on my graph. But for my domain and range, for a discrete function, I'm still just going to be making a list of the x and y values for those points. So if you need to, you can take the time to go ahead and list out what your coordinates are and write them on your graph. Remember, this point right here is 0, 0. And I'll do it in yellow here that I'm highlighting right here. That's a big yellow line. I'll go ahead and draw it in here in this yellow. That is 0, 0. So you can go left, right, up, or down. Remember, x values are left and right. Y values are up and down. So if you wanted to list out the coordinates of our points, this one would be -1, 0. This would be 1, 2, 3, 4, and then -2, -2. Because I'm left 2, left 3, -3, 2, -3, -2. So once you have that list, really it's just going ahead and, just like we did from our set of points, list our x values for our domain. So in this case, -3, -1, 1, and 3. And then for our range, we've got -2, 0, 2, and 4. And that would be our domain and range for that graph, for that function. For number 5, here a little bit more unique because, again, I can go ahead and list out the coordinates. -2, -2, -1, 0, 0, 2, 1, 0, and then 2, -2. Because my x values here are still unique, so my domain is still unique. I have all 5 of those values. -2, -1, 0, 1, and 2. But my y values, you can see this point and this point have the same y value, -2. This one and this one have the same y value of 0. So I only really have 3 distinct y values in my graph. And those would be -2, 0, and 2. All right, now on to the trickier stuff. So when we're dealing with a continuous function, a continuous graph, meaning all of these points along my blue lines here are points on my function, meaning those are different x values, different y values for which my function exists. Those are my different possibilities. So what we have to look at here, I have to basically take a 2-dimensional shape and kind of just focus in on a single dimension. I have to either look at how far left and right it goes, how far left and right my function exists for, or how far up and down my function exists for. So in this case, left and right, that is my x values. So I'm looking at how far left it goes for the leftmost x value, the lowest most x value, how far right it goes for the furthest most x values. So I'm going to go ahead and use my yellow highlighter here. The way I like doing this, I like to draw these, I want my yellow highlighter here. I draw these vertical lines just to show how far left my function goes and how far right my function goes. Because now what I have to do is take that left and right inequality basically and write my compound inequality, right, between -2 and +3 are all the places my x value exists. So in this case, my domain, since it's a closed circle on the left side at -2 and a closed side on the right side at +3, my domain is going to be -2 less than or equal to x less than or equal to 3. Because my x values go as far left as -2, including -2 because it's a closed circle, And my x values go as far right as positive 3, including positive 3, because again, it's a closed circle. For my y values, I'm again going to do the same thing, except here, oh Lord, that's a big highlighter, but that's okay. We'll make adjustments. So here, the lowest my graph goes is -1. The highest my graph goes is a positive 2. So when I write my inequality for the range of my function here, range being my y values, -1 is the smallest, less than or equal to, my y value goes up to positive 2. So -1 less than or equal to y, less than or equal to 2. So again, -1 is the smallest y value, positive 2 is the biggest y value, and here, since it was closed circles, we put the or equal to. All right, last one. And this one's a little bit tricky because here, if I start with my domain, I go as far left as this point right here at positive 1. But you can see my arrows on the ends tell me that my graph continues going as far right as it wants to, meaning I don't have an upper bound. I don't have an upper limit that stops my graph from moving right. It goes as far as it wants to. So in this case, if all of my x values just have to be bigger than or equal to positive 1, I'm just going to go ahead and write that. I'm just going to say all of my x values have to be bigger than or equal to positive 1, because I don't have a biggest number that my x's exist for. It just keeps going as far to the right as it wants to. And my range is even weirder because, like you can see, these arrows go up and down. It goes up as far as it wants to, even though it goes at an angle. It goes down as far as it wants to. It's at an angle. So it goes everywhere it wants to vertically for our y values. So we go back to all real numbers. Any real number is a possibility for my outputs because of the way my graph is shaped. All right, so that's a little bit of everything for domain and range. Your homework today is going to be the relation and functions worksheet. So that one, you're given a bunch of functions or possible functions. You have to identify the domain and range, and then identify if it is a function as well. So do the domain and range first, because you can find the domain and range even if it isn't a function, even if it fails vertical line test, or you've got repeated x values that go to different y values. But that's what you're doing for your homework today. So you can find that a physical copy if you're here in person, or it's always, as always, it's posted on Google Classroom for those working remotely. If you have any questions, don't hesitate to ask. Make sure you guys are just reaching out and letting me know. Have a fantastic day, and I'll see you guys soon.